Hello and welcome to today's Saturday session. Today's lesson will be focused on Leaving Cert Physical Education and a common exam question breakdown. So the focus of today's lesson will be biomechanics, specifically focusing on learning outcome 1.2, which aims to analyse skill and technique from a variety of perspectives. So a common question that can come up is different movements in the different planes and axes. So here in 2020, question 1, we were asked to identify the axis and plane of the hammer thrower in the figure above. So it's important to look at the action verb that the exam is using and what we are being asked to do. So here we're being asked to identify. It's important to note that identify means to name and state a brief fact and provide a distinguishing fact as well. So we can see here the marking scheme just has the identification of the vertical or longitudinal axis, and then the identification of the plane as transverse or horizontal. We can see here on the next slide, gone into a bit more detail, and we have named, as we can see here in the red writing, the axis, which is the vertical axis, which is the line that is coming right through our body, as we can see here in the diagram below. And then we have a distinguishing fact, so it runs through the body vertically from top to bottom. Then with the plane, we have named the plane that it's in as well, so the transverse plane, which divides the body into lower and upper halves equally. And also stating another brief fact about it then, movements in this plane are rotational. So as you can see here, with the hammer throw, it's a rotational movement. And that's just adding a bit more detail to our answer. Instead of just naming the plane and the axis, we're able to state in brief facts and distinguishing facts to showcase our knowledge. A common question in the written examination is lever classes and identifying them in different movements. This was asked in 2020. So we can see here a javelin thrower competing, and we were asked to identify the class of lever operating at the elbow when throwing the javelin. So when we are looking at lever classes, we need to understand what a lever class is made up of, the components of a lever. So we have the load, which is the weight or the resistance being applied. So in this instance or this scenario, it's the javelin, which is the load that the thrower is trying to throw. The effort is the work done by the specific muscle in the movement. The fulcrum is the point or the joint if it's a body, a human body that's performing the movement, at which the lever rotates, and then the lever arm, which is the bone or the object acting as the lever arm. So as we can see in this scenario, we have the javelin as the resistance. The effort is being done by the triceps muscle, which is extending the elbow. The fulcrum point or the joint is the elbow joint, and the lever arm is the lower arm here. So from the elbow down to the hand, that is the lever arm that's operating here in this scenario. So here we go again. So we have the load here identified with the red arrow. The effort is the triceps muscle, which is extending the elbow as the javelin thrower follows through on her throw. And the elbow then is the fulcrum, so the pivot point which the lower arm is moving. So if we go back to the question we were asked to identify the class of lever that was operating at the elbow. So it can be quite useful to identify the fulcrum, the load, and also the effort when we're trying to identify what class of a lever it is. What we know what levers is a little mnemonic device here. So we have our first class lever, our second class lever, and our third class lever. We know that in our first class levers, the fulcrum is always in the middle of the load and the effort. So 1 matches to F. At our second class levers, we always know that our load is in the middle of the fulcrum and the effort. And then our third class levers, the effort is always in the middle of the load and the fulcrum. So the little memory device here is 1, 2, 3 FLE. So if we're wondering, trying to figure out what class of a lever is operating at a certain point, we can use the 1, 2, 3 FLE to try and figure this out, and then draw it out on the actual exam, or that if you didn't have a picture of it, you could draw it out on your rough worksheets yourself. So as you can see here again, what we would do is we identify the load, which is the javelin, the fulcrum, which is the elbow, and then the effort, which is the muscle group that's working, which is the tricep. And as we can see here, the fulcrum is in the middle of the effort and the load. So if we apply our 1, 2, 3 FLE, we know that 1 matches with F, and that our lever that is operating here is a first class lever. And again, if we are using the action verb that we were asked in the examination, so to identify, which means to name, state a brief fact, and provide a distinguishing fact, we know the lever is a first class lever because the fulcrum is in the middle of the javelin, which is the resistance, and the effort, which is the muscle group that is working. And there we are providing again the name, we are stating brief facts, and we are identifying the resistance and the effort, and also providing distinguishing facts showing that we know why it's a first class lever, as well as just putting down that it is a first class lever. So another potential question which could be asked is to explain the planes of movement or the axis of movement. So this time in 2021 we were asked to explain the frontal plane of movement from a biomechanical perspective and give 2 examples of movement in the frontal plane in physical activity. So to explain means to give a detailed account, including reasons or causes. So as we can see here, this is the marking scheme here. So you can see we have 4 marks and then 2 marks plus 2 marks for the examples. So again, we're looking for a detailed account, so we're looking to give as much detail and as many reasons or causes if that's applicable. So starting off, we're just going to explain what a plane is. So a plane is an imaginary flat surface running through the body. So when I'm thinking of planes and axis, when I think of plane, I think of pane. So if we saw the picture that we had earlier on of the transverse plane that we had, so it looks like a pane of glass. So that's why that's one way you can use to remember it. Is so plane looks like a pane of glass. So it's an imaginary flat surface running through the body. All body movements occur in different planes. So again, given more detail on planes and their application to biomechanics and to movement. The frontal plane, so you're identifying which one it is. It splits the body vertically into front and back halves, and each half is of equal mass. Then you're demonstrating your knowledge of the frontal plane with regard to movement. So the movements in the frontal plane are always sideways or lateral movements. And the examples of frontal plane movements are abduction and adduction. So they're the anatomical movements. So You're looking at abduction, which is moving your leg straight out to the side or moving your arm straight out to the side, and then adduction, which is moving your leg back in towards your body or moving your arm back in towards your body. Two examples then of frontal plane movements. So in this examination they were quite general, so you could have given cartwheel or sidestep or jumping jacks, but what they may ask for in different examinations is they may ask for movements, they may ask for skills. So if we're looking at movements here in a more fitness or training environment, you're looking at jumping jacks. The lateral lunges is another example of a resistance training movement, or a lateral raise is another example of a movement in the frontal plane. Now if we're looking at skills in the frontal plane, we will be looking more at something like a cartwheel or a sidestep in rugby. So they're actual skills that are performed in a sport. Another question which is asking to identify a class of a lever. So for this question, they're asking a question where the oar is acting as a lever. So what they're looking for is, for the rower, identify which class of lever the oar is. So it's important to read the question and to identify that they're looking for the class of lever at the oar as opposed to at a specific joint in the human body. So this is the image provided in the examination paper. So again, we're trying to identify the load, the effort, and the fulcrum. So it's for the oar this time. So with the load, the resistance or the load is being applied by the water. So they're pulling the oar against the water, so the resistance is being provided by the water. The effort is the pulling motion of the rower who's pulling the oar, and the fulcrum is the oar lock, or the point on the boat where the oar is connected to the boat. So again, they're looking for us to identify the class of lever. So for the identification, we're looking to name, we're looking to state a brief fact, and we're looking to provide a distinguishing fact. So when we're looking to name it, then we're naming it as a first class lever, as you can see written in red here. And again, we're distinguishing why it's a first class lever, because the fulcrum is in the middle of the load and the effort. And then in brackets, we're also stating brief facts to supplement this. So we're identifying that the resistance is provided by the water and that the effort is the pulling motion of the paddle by the rower. So another type of question you can be asked in relation to biomechanics in the Leaving Cert P exam is on vectors and scalars and your knowledge of them. So this question is asking to explain the difference between distance and displacement. So just as a little test midway through this lesson, I'm going to ask a question based on the run on track you can see below here. So if you run 400 meters around this track on the inside lane, what is your distance covered and what is your displacement? So I'll give 15 seconds or so. So the distance covered, if you run around in lane 1 from start to finish, is 400 meters. As distance is a scalar metric. So a scalar means that it's relating to the magnitude or number only. the displacement is 0 meters, as this is a vector. So you start at the start line, you run 400 meters, you finish at the start line again. So your overall displacement from where you started is 0. So displacement is a vector. It has to do with the magnitude or the number, and also it has to do with direction as well. So that is why the displacement would be equal to 0. So for this question, they were looking for us to explain, which means to give a detailed account, including the reasons or the causes. So the reasons in this scenario. So distance is a scalar quantity, which means it's described in terms of its magnitude. So it's a numerical value. So again, so 400 meters would be the magnitude. Distance measures the path of a body from one start to another finish point. So if you could imagine if you were driving from Ireland's highest point to Ireland's lowest point, so from Mallinhead to Mizenhead, so distance measures the path that you would drive all along that journey. However, then displacement is a vector quantity, which means it's described in terms of its magnitude and its direction. So displacement measures the shortest distance between 2 points. So if a person was driving from Mallinhead to Mizenhead, they would drive for that distance, and the distance would include all of that route, whereas the displacement would be as the crow flies. So if a crow was to fly from Mallinhead to Mizenhead, the displacement would be much shorter, as they would go in a straight line from the 2 points. Another example of distance is a ball that is kicked 10 meters. So we know the magnitude of it. And an example of displacement is a ball that is kicked 10 meters to the right. So we know the magnitude, so the distance or how far it went, and also the direction that it went in. So the next part of that question is looking at what we did previously. So calculating the distance and the displacement of an athlete having competed a 400 meter sprint in lane 1. So if we imagine we have a GPS trace here starting in lane 1 and sprinting all the way around the 400 meter track, that would be our distance. So our distance would be 400 meters, whereas our displacement, so this is where we started in lane 1 at the X, we sprinted all the way around back to the X, so our displacement point here at the X would be 0, as we travelled 400 meters, but we didn't move from our start point. We returned back to our start point again, so our displacement would be equal to 0. The next part of this question was calculating the average speed from the 200 meter to the 300 meter point during this race. So you're given the distance, and you're also given the speed, or you're also given the time, and then we're looking to try and calculate the speed. So if we have Dad's silly triangle over here on the left hand side, we know that we have the distance, which would be 100 meters. So if we run from 200 meters to the 300 meter point, that would be 100 meters. We also have the time, which is 10.5 seconds. So we need to calculate the speed. So we are looking to divide the distance by the time. So as you can see here, the average speed will be the distance travelled divided by the total time spent travelling. So we have our distance, which is 100 meters. You can see we have underlined meters here, divided by 10.5 seconds. See, we've underlined seconds here as well, and that will give us our average speed. So it's important to note that in this examination in the marking scheme, that if you gave 9.5 as an answer, just a number, you got 1 mark. But if you gave 9.5 meters per second, which is the number and also the unit, you got the full marks. So you got the 2 marks in the question. So it's important to include the units as well as the values when you're doing these questions. So moving on to the 2022 paper. This question asks us to name the plane and the axis through which a discus thrower moves when they spin before they release the discus. So as you can see, I've put in a little image of a discus thrower through the various stages, so the swing phase, the turn phase, and the throwing phase of the discus throw. And I'm going to give again about 15 or 20 seconds, and I'm going to see if you can identify the plane and the axis that the discus thrower moves before they release the discus. So if we're looking at the plane, so these are the planes of motion. So we have the transverse plane, we have the frontal plane and the sagittal plane. So as you can see here, the plane looks like a pane of glass dissecting the body. So as you can see, the transverse plane cuts it into top and bottom halves, the frontal plane into front and back, and the sagittal into left and right. So see if you can identify the plane through which the discus thrower will be moving before they throw. Then we have the axes. So for the different axes, we have the vertical axis. We see the arrows now pointing down and then forward and back, and then left and right. So we see the vertical axis. We can see the frontal axis going from left to right or right to left, and then we can see the sagittal axis going from front to back or back to front. So try and identify which axis is the discus thrower using when they're throwing the discus. The answer is the vertical axis or the transverse plane. So what I've just presented here a minute ago with the different axes, the different planes is the way that you might think about answering a question like that. So try and think about which plane that the movement is taking place in, and also which axis the movement is taking place in. So for this question, the vertical axis is the axis the movement's taking place in. So you can see the line running through the body from the head down. So you can imagine if you grabbed the top of this line, and if it were running through the discus thrower's body, and if we twisted it, that would be the axis. Okay, that would be the axis, that would be the movement, and then the transverse plane is the plane in which the movement is taking place. So it's a rotational movement. The plane would be the transverse plane, and the axis would be the vertical axis. And then the second part of this question asks us to identify a movement from a physical activity of choice that is in the same plane and axis as the discus thrower. So it's a rotational movement we're looking for. So different examples that we could use here are the physical activity could be ballet, and we could be looking at a pirouette, and another rotational movement could be a gymnastics, a twist in gymnastics. The physical activity could be gymnastics, the movement could be a twist. And again, there's plenty of other examples from sport and different physical activities. So a golf swing is another rotational movement that could be used as well. The third part of this question then relates to vectors and scalars questions again. So they're asking us to identify whether speed, velocity, and momentum are vectors or scalar quantities. So in order to picture this, so we're going to look at the t-test, which is a common test which is taken or which is completed as part of the physical activity project. And we're going to use this as an example to look at the speed, the velocity, and the momentum. So if we imagine if we have an athlete that's 100 kilos, 100 kilograms, and is running from cone 1 to cone 2, what would our speed, our velocity, and our momentum be? So again, I'll give 15 seconds. Just try and think of what the speed, the velocity, and the momentum would be. So the 100 kilo athlete, they are going from cone 1 to cone 2 in 1 second. What is their speed, what is their velocity, and what is their momentum? So if we look at the athlete A running from cone 1 to cone 2 in 1 second, the athlete has a mass of 100 kilograms. Their speed would be 5 meters divided by 1 second, which would be 5 meters per second. So speed is a scalar quantity. It's concerned only with the magnitude. Okay, so only the magnitude. The velocity then, as we mentioned earlier in the lesson, is concerned with the magnitude and the direction. So if we look at the velocity, it would be 5 meters divided by 1 second, but the answer would be, in this test, the velocity from cone 1 to cone 2 would be 5 meters per second to the right. So the athlete would be moving from cone 1 to cone 2, which is in the right direction. So they would be moving to the right, and that means, so the answer to the question they've asked above is that velocity is a vector quantity, as it includes both magnitude but also the direction. And for the momentum is equal to the velocity multiplied by the mass. So we have the velocity, which is 5 meters per second by 100 kgs, and we have 500 kg meters per second to the right. So again, just an example of them in use, but speed is a scalar quantity. It is concerned only with the magnitude, and then the velocity and the momentum are vector quantities, so they're concerned with the magnitude but also the direction. So if we're looking at this t-test one more time, if you're moving from cone 1 to cone 2, the speed is 5 meters per second. The velocity would be 5 meters per second to the right. The momentum would be 500 kg meters per second to the right. And then a follow-up question from that, it asked to provide a reason why velocity was categorized as a vector or scalar quantity. So we're explaining in this question what a vector is. So a vector is a quantity that has both magnitude and also direction. Velocity was categorized as a vector quantity because it's equal to the displacement divided by time and has a direction and a magnitude. So that's velocities. What it's equal to the displacement divided by the time, whereas speed is equal to distance divided by time. So the next question from 2022, section C, so the longer questions, is related to Newton's laws and how they apply to performance in a physical activity that you choose. So for these questions, it can be quite useful to write out the Newton's laws on some spare worksheets that you have, just so you can have them available, and then they can be then applied to the sport. So once you have them, and this can be quite useful. It might be easier to do than trying to think of applying the law to a sport and having to write it all at one time. So if you have the laws in front of you, like they are here on the screen, then they can be more easily applied to the activity. So we have the law of inertia here. An object at rest will remain so, and a body in motion will also remain in motion with a velocity unless it's acted upon by an external or outside force. Newton's second law, the law of acceleration, so force is equal to mass times acceleration. Object will accelerate relative to the force applied and in the direction that the force is applied. And Newton's third law, the law of reaction, so every action has an equal and opposite reaction. So if we look at a sprinter taking off from the blocks, it can be used to apply Newton's first law to this activity. So an object at rest will remain so, and a body in motion will remain in motion with a velocity unless it's acted upon by an external force. So the way that you could apply this to sprinting is a sprinter on the blocks will remain at rest unless an external force is applied by the sprinter into the blocks, causing them to move. Similarly, in a rugby context, you could state that a rugby player in motion will remain in motion with a velocity unless it is acted upon by an external force from another player tackling this player. So that's the application of Newton's first law, the law of inertia, to rugby. So if we look at Newton's second law, the law of acceleration, so force is equal to mass times acceleration, an object accelerates relative to the force applied and in the direction of the force. So again, if we look at the sprinter taking off from the blocks, this sprinter will accelerate relative to the force applied and in the direction of the force. So if we look at the arrow here, that is the direction in which the force is being applied. As you can see, the sprinter here in this picture is moving in the direction that the arrow is moving in the opposite direction that the arrow is going to. So again, the sprinter is accelerating relative to the force that they're applying into the blocks and in the direction that the force is being applied. Again, if we look at a rugby context and we take the rugby ball in this scenario, the rugby ball will accelerate relative to the force applied and in the direction of the force. So again, the force applied by the foot of the kicker and in the direction of the force that the foot is kicking the ball. So again, the kicker will be trying to kick the ball towards the posts, but if the foot moves slightly and directs the ball towards another direction, then the ball will not move towards the post. That's Newton's second law, the law of acceleration, in practice in both sprinting and rugby. And then if we look at Newton's third law with regards to sprinting again, we have the law of reaction. So every action has an equal and opposite reaction. So if we look at the sprinter here, when they put their foot down into the ground, the force that they are applying into the ground is equal to the force that the ground is applying back up into the foot. So again, the amount of force that the sprinter puts into the ground will be equal and opposite to the force that the ground is putting back up into the foot, which propels the sprinter forward. Again, if we apply Newton's third law, the law of reaction, to rugby, so every action has an equal and opposite reaction. So a scrum that is stationary and not moving, with players that are actively trying to move against each other, will have equal and opposite forces being applied. So that's Newton's third law the law of reaction applied in a sprinting and also a rugby context. And again, these are just examples. They can be applied with different scenarios with different sports as well, and you can use your imagination, but it can be quite useful to have the definitions there and be able to think of how the laws apply to sport, while having the definitions or the Newton's laws there in front of you. So that might be a useful trick for an exam if you encounter a question like this. So this question in 2022 asked students to complete the following table and provide examples of physical activities, skills and techniques, and joint actions that are exclusive to different classes of lever. So for lever classes, first class levers with regards to movement, so an elbow extension, when you extend or you straighten your elbow, it will always be a first class lever. An example of a second class lever is plantar flexion, and then all other movements are third class levers. So again, plantar flexion, second class lever, elbow extension is a first class lever, and then all other movements are third class levers. So again, we'll run through those in more detail now. So again, we're looking to think of where the load, the effort, and the fulcrum here is. So again, if you are presented with this question in an exam, what you could do is you could draw out the movement or the skill being performed on some spare worksheets. You could identify where the load, the effort, and the fulcrum is, and you could use this to see whether the lever is a first, second, or third class lever. So again, for the first example here, for the backhand in tennis, we can see here that the load is the tennis ball. Okay, so the tennis ball is what is providing the resistance. The effort is the tricep muscle, which extends or straightens the elbow. And the fulcrum is the elbow joint. So as we can see here, we have the fulcrum in the middle of the load and the effort. So if we apply our 1, 2, 3 FLE, we can see the 1 matches with F, so we know that's 1 is our fulcrum, so our first class lever is our fulcrum. So if we drew out this action in an exam, that might be useful, but again, we know that a first class lever in terms of movements is our elbow extension, so any activity that involves an elbow extension. For our second class lever then, we have our effort, which is provided by our calf muscle. We have our load, which is provided by our body weight, and then we have our fulcrum, which is our ankle joint here. And as we can see, the load is in the middle of the fulcrum and the effort. And if we apply our 1, 2, 3 FLE, then we know that our load is in the middle, and this is a class 2 lever. So again, our plantar flexion, or standing on our tippy toes, is an example of class 2 lever. So any activity that involves this movement, plantar flexion, and an example of this in a sport or activity is a pirouette in ballet. And then if we look at our third class lever, we can see here that the load or the resistance is being provided by the ball. The effort is being provided by the quadricep muscle, which is extending or straightening the knee, and then the fulcrum is the knee joint. And as we can see, the effort is in the middle here of the fulcrum and the load. If we apply our 1, 2, 3 FLE again, we can see that the effort is in the middle, and we know that this is a class 3 lever. So again, a punt kick in Gaelic football is the example of our class 3 lever in this instance. So at the end of this question, they asked to explain how the skill or technique that was identified by you in the first question uses that class lever. So you asked to select one. So explain means to give a detailed account, including reasons or causes. So again, that's our action verb that we're looking to achieve. So again, the class of lever that I selected was the third class lever. The skill of punt kicking in Gaelic football uses the third class lever, as the load or resistance is the mass of the football, and also that's combined with gravity, so gravity will be pushing the football down. The fulcrum is the knee joint which moves or rotates the lever of the lower leg. The effort is the work done by the quadriceps muscle which extends the knee joint. So again, we're just explaining the load or resistance, we're explaining the fulcrum, we're also explaining the effort in relation to this specific skill. And then we're making sure that the examiner knows that we know that the effort is in the middle of the load and the fulcrum, meaning that the skill of punt kicking the Gaelic football uses a third class lever. These next few questions are from the most recent 2023 Leaving Certificate Physical Education Higher Level paper. So question 1b on this paper was concerned with planes, axis, levers. So the question asks us to describe the two planes of human movement that we were asked to detail above. So again, so question A asks us to just identify or to name two planes of human movement. So again, we would be identifying the frontal plane, the sagittal plane, or the transverse plane. And then section B, so part B of the question, asks us to use a sporting example of movement in each of the planes to support your answer. They asked us for two of them. So for the first question, we are looking to just describe, so it means to develop a detailed picture or an image of. So again, they're asking us to describe the plane of human movement. So the frontal plane of human movement is an imaginary flat rectangular surface running through the body, dividing the body equally into front and back. So again, we're explaining what a plane is and also what the frontal plane is and providing a detailed image or picture of that. And then providing the sporting example, frontal plane movements are lateral or sideways, so that's the actual movements that can take place in the frontal plane. And a sporting example of a frontal plane movement is the sidestep in rugby, but you can provide your own answer there, or whatever answer or example that you would like to, as long as it is in the frontal plane or it's a lateral or sideways movement. So same again for the second question. The transverse plane of human movement. So we're explaining what the plane is, or what a plane is. It's an imaginary flat rectangular surface running through the body, dividing the body equally into top and bottom. So that's the transverse plane. Transverse plane movements are rotational, so like we had earlier with our hammer throw, our pirouette, our gymnastics twist. And a sporting example of a transverse plane movement is our hammer or our discus throw. So 2023 question 7 asked us to which of Newton's laws can be used to calculate the acceleration of a rugby ball which has been kicked. So again, with Newton's laws, it'd be no harm to write these out on some spare worksheets in order to identify which one could be used to calculate the acceleration of a rugby ball. So again, we'll know that this will be Newton's law, Newton's second law, which is force equals mass times acceleration. So in order to calculate the acceleration, you'd have if we had the force and the mass, we would be able to calculate the acceleration of the rugby ball. So that law of motion, Newton's second law, would allow us to do so. And then the second part of the question, we were asked to name and define another one of Newton's laws of motion. So again, this is just asking for the naming and the definition of the law of motion. So again, learning these and being able to write them out, whether it's for a question, as if it's asked here, or whether it's just for rough work in a question where you're asked to apply Newton's laws of motion to an activity like we were asked to do in one of the earlier exam questions in this lesson, can be quite a useful thing to do. So again, learning and becoming familiar with and comfortable with Newton's laws of motion can definitely be useful for the Leaving Cert P exam. And the third part of this question asks to explain why Newton's laws of motion would be used to analyze human movement. So the main reasons Newton's laws of motion are used to analyze human movement is to improve the technical execution of skill. So for example, if a sprinter would strike the ground with their heel instead of the ball of their foot, the force they put into the ground would be reduced. And the equal and opposite force from the ground that moves the sprinter forward will also be reduced. So a coach can use their knowledge of Newton's laws to help the athlete improve the technique and the way that they apply forces. So if we're looking at up here at the example provided, we have an example of Newton's second law and Newton's third law. So we know that forces and the direction that these forces are applied in are very important, as this will dictate how an object or a person accelerates. So in sprinting, we're trying to contact the ground with the ball of our foot. So if we don't contact the ground with the ball of our foot and we contact with our heel, then this will reduce our ability to put force into the ground. So again, Newton's second law being applied here in the technical execution of sprinting. We also know that if the sprinter contacts the ground with their heel instead of the ball of their foot, then they're not going to apply the right amount of force into the ground, which is going to reduce the amount of force that is coming from the ground back up into the foot, as we know that for every action there's an equal and opposite reaction or an equal and opposite force, and then that means that the forces from the ground into the sprinter's leg will be reduced, and these forces are the ones that propel a sprinter forward, and that will reduce the speed of the sprinter. So again, we know that Newton's laws of motion are implemented or applied by coaches when they're trying to improve technique of a certain skill. And that's the end of our presentation. So thanks very much for taking part in this Saturday session. I hope it was helpful, and all the best with your studies.